morning from Jota to everyone. So could anyone respond that you can hear me clear?
Yes, sir.
Thank you very much. So Syukur Alhamdulillah, we can meet again today on the 15th of November 2021, equivalent to 10 of Rabiul Akhir. Our class is 1 hour class, 10 to 11. Syukur Alhamdulillah, we can meet again. So we are going to continue the lecture that we talked yesterday. Yeah. So we are going to move to allow me to to close this one, and I'm going to open up another file. This one allow me to share with you this. For example, you can turn your books on page 187. You have the equation that, and you also have the solution with you. So I'm going to I'm going to use the solution as the discussion here. So I'm going to open another file. And I'm going to move to the chapter, this one. You have the new screen with you, class? 187.
Yes, Doctor.
Thank you. Yeah. I'm going to explain based on what you have in your notes, yeah, so that you can easily check and you can use that as a reference to answer all questions related to the course, okay, or related to the topics. Okay, let me check my. Okay, so I'm going to use this one. Okay, now. So example number 6 on page 187, this one. And you can use this example as reference to answer any other question related to topics. Typically on the vehicles, we are engine automobile traveling along the track of 100-meter wind radius. This one is basically, remember, traveling along the track is the radius of curvature, is 0. Each of the wheel has moment inertia 2.5 each. You're talking about automobile, you have to multiply by 4 because each one each 2.5 kilogram meter. Effective diameter 0.6 is basically the radius of wheel or wheel radius. The rotating part of the engine have moment of inertia 1.2. Remember, you have I engine, you have I wheel. This is your solution, yeah. And and you have the engine axis is parallel to rear axle. So you have the engine axis is parallel to the rear axle. So you have M total is equal to M engine plus M with M is couple. Okay. And what else? The ratio of the engine speed to back axle is 4 to 1. This is the ratio. So the ratio is the you can put this one, the omega E divided by the omega wheel is equal to 4 by 1. Or on the other hand, you can also use omega E for engine, yeah, is equal to 4 times of the omega wheel. Okay. Let me close my WhatsApp application here. So you have, and they mentioned also the width. The width is, remember, the width of the track is 1.5 is the x from axle or from wheel to wheel. You have another one. This one. This one h will be the height from the center of gravity to the level or the surface of the road. The other one is x. Okay. Determine the limiting speed. We are going to look for the limiting speed. Sometimes they call the maximum speed. Sometimes they call the limiting speed. Okay. So what will be the limiting speed of the vehicle if the wheel of the vehicle take a right bend, turn to right around the curve for all wheel to maintain contact with the road surface to ensure that all the wheel on the surface will not leave the ground or leave the surface. So we are going to look for the stability of equation, as I mentioned earlier, isn't it? So the stability equation, if you go back to the equation, is basically given by the equation of statics and also the dynamics. This is the stability dimension. This one, yeah, stability equation. This is statics due to static. This one is due to dynamics. One is due to one will be due to the centrifugal. The other one is due to gyroscopics. So it's basically static and dynamic. Okay. Move to the solution just now. And this is the engine ratio. This is not the gear ratio because we studied the gear ratio. Remember, the gear ratio is equal to omega O by omega I is equal to the omega O is wheel. This one is omega N. So this is not the gear ratio of the entire gearbox. No, this one is the ratio at that particular instant when the vehicle running at 100 kilometer per hour for the speedometer. So the tachometer show you at 3,500 RPM, for example. Okay, or it could be in terms of ratio. This one, this is the ratio. This one, yeah, this one, yeah, 1/1. Okay, so you have to read the equation. Sometimes it's not given you the ratio of the engine speed to the back axle, but instead at that particular instant of the speed which shown by the tachometer and also speedometer. Okay, we are going to look for the limiting speeds or perhaps the maximum speed in such manner that all the four wheels will remain on the ground, will not leave the ground. Okay, so these are the equation. So gear ratio given, or perhaps in other words, this one is the angular. Remember, the angle velocity of the wind. This is coming from the equation of V equal to omega for boats. You have this one. So you have omega wind equal to 4 velocity. This one is omega E is equal to 16 velocity. 16 multiplied by V is the velocity. Okay. So our aims now is to define this one, the velocity. So that is our aims. So you move on. So I did mention about you have four effects. One will be the effect from the vehicles or perhaps the MG. The other one is gyroscopics. The other one is scientific. And you have another one which is not in our concern. Yeah? It's basically due to the what you call it drag friction, which is not in these topics. Okay. Again, the drag friction is basically on statics again. So let's focus on what we learned in class. So we have the effect of weight vehicles divided by 4 as usual, and we are assuming it fall at the center. Mg fall at the center. And again, we are also assuming that the CG is fall at center, and you have 4 wheel divided by 4, you have this one. This one is on the on the wheel. At this one toward the surface. This one is on the wheel from the surface. Is the reaction. This one is the action. This one is the reaction. As I mentioned earlier, isn't it? Yesterday, you have a solid wall, you hit the solid wall. The solid wall won't hit you back, but you will feel the pain. So the more force you put on the solid wall, the more pain you will feel. Sir. Unless you are hitting a boxing, the punching bag, for example. They want some of the different thing. Yeah, you punch the punching bag, so the punching bag fly or like the paddle, then the punching back to you, isn't it? So this one talking about solid wall because this is solid. This one is all solid. I'm sorry about my voice again. Yeah. Effect of just coupled. This one the first effect. This one the second effects. While take right turn. So this one is positive, remember, because as mentioned just now, since the axis parallel to the y-axis, I did mention this one, the reasoning why you take positive, and this one is the reason. Then you start calculating one after another. Calculate the ME, the couple due to the engine, the other couple due to the wheels. So you know that the only unknown parameter is V and other V. Then you add up together, we have this one. So this is the total, M total. G stands for gyroscopic. Yeah? T stands for total and G stands for gyroscopic for boats. Then you know that you have to transfer this force, this moment, this moment by the axle. This is the axle. This one is the wheel. This is the axle. and the distance is x. This x is 1.5. You know this one moment. You do not know where the moment is. The moment that the couple could be that way, or the couple can be that way. It doesn't matter. If this one is m, for example, this one the m prime, doesn't matter. But the magnitude is what we concern, isn't it? So you have m multiply is equal to f. We do not know where f is, multiplied by x. Then you will have this one, correct? Then you simplify, you make it as this one. But remember, this one is the rear wheel. We have another one, the front wheel. So that is why we divide it by 2. You divide it by 2, you have this value. Okay, then only you want to, you want to ensure that where will be this FG, acting on the wheel. So what you're going to construct the gyroscopic vector diagram. Okay, this omega is always on wheel. On wheel, why? Because the wheel make the car move from one station to another station. So if I can on my wheel, my if I can on my, where are you? Video. Yeah. So this one, move forward. So this one, the spin is pointing that way, correct? So you have this one. Then the vehicle turn to left. This one left pointing upward, my left pointing upward. This is pointing right, down, pointing downward. So the precision will be pointing downward. So you have this one pointing downward. This is for 2D. If you're creating or constructing the 2D, 3D, you're beginning as such. Okay. So now we are spin. You have precession. The next one is couple, which is now pointing to the screen or the the computer screens. Yeah. So if you're pointing this one, you know that this one is the active. This one, cos the active. And the reactive will be pointing to you back with the same magnitude but different in direction. So this one active, this one, and you have to understand what is the active and reactive in here. It is very difficult. Sorry, it is very different from what we have learned in, roto. The other one is the aircraft and also naval ship. Here, this is the active pointing inward of the screen, and this one is the reactive. And the active is basically on wheel because we are dealing with wheel at the moment. So this one all dealing with main. And also it's not wheel. Also a part of that we have the engine because remember this M total is due to M wheel plus M engine. So that is why it's due to that one. Okay, so anything beyond that, if you want to look for the reaction, for example, yeah, on body or perhaps on bearing. So you have to look this one, the reactive. So you have to read the question very, very careful. At the moment, the question asks us to define what will be the maximum speed or the limiting speed in such manner that the vehicle will not run off the road. So we are concerned is to look for on wheel. It's not on the body. On wheel. So we want to ensure that which wheel has a tendency to leave the ground. Okay. So now we start considering this one, and this one is the M active. M active is pointing screen will be rotating clockwise from your seat, isn't it? So this one is clockwise from seat. So you have creating this one is clockwise from your seat. And you have one pointing upward, the other one pointing downward. You understand me or not, class? And I'm explaining this one in these sentences and you can read on your own. Is that clear? Okay. I hope you're clear, yeah? So the next thing is talking about the effect on centrifugal. Centrifugal effect are based on when you turn left and then turn right. If you don't turn left and right, there will be no effect on centrifugals. Yeah? So on centrifugal again, do not memorize the equation. You have to understand on your own. This one is the equation that we use. Typically, you learn in dynamics F equal to man. Remember, this one man is equal to m omega square r. Can also be in the form of m v squared by r. But if you look at the radius, it's not consistent or not constant. You can change that one to become mv squared by rho. Okay, so now you put this one in this manner, you have this one as such. But of course, the very beginning you will have as such. Then again, you need to transfer this force on the wheel, on this wheel. How is it? It's not very difficult. Look at here. Again, yeah, I'm constructing this one. So this one, supposing this one is with, supposing, okay, sorry. It's not correct. It's not correct. It's not correct. Supposing you have a vehicle as such. This one from rear, yeah, from rear. It's a wheel. It's a wheel. Center of gravity. And the center of gravity, measured from the surface is h. And you will be calculating the f just now, which is if you turn to left, turn to left pointing that way, turn to right pointing that way. So if I can, this is the vehicle. So this is your row, always pointing inward of the curvature. So you will have this one. Let me use another color here. You will have here F N, and this one, of course, your F C. Is that clear? Okay, so this is Fn now. So how is it? It's not very difficult again. Okay, you already have this one, 16. This one, a couple tending to run the vehicle. You have the 18. This one is 16V. Sorry, 16V. Okay, this one is FC. Put it here. 16 multiplied by 0.5 is the distance. Sorry, the H. H will be, this one is 0.5. So you will have the couples. Couple is basically whatever you have multiplied by the H. This is the F centrifugal. You have 8V. And remember this one, this 8V is not the actual thing. It's basically for one axle. You have another axle. So that's why you have to divide it by 2. Then you simplify this one, it's becoming this one, 5.33V, isn't it? But remember, you have 2 axle, front axle and rear axle. So this one, another one for 2 axle. So you calculate that the actual thing, then you understand that it's not only F but basically FC. Okay, so if you can construct the reaction action, this one is the action, isn't it? This one is the reaction. So this one is, because you turn to left, you have this one, and again, yeah, it's this one. You have this one. You put it there. You have FC. You have another FC, and your FC is 2.667V squared. So now you have three forces: on static, on gyroscopic. The other one is on the centrifugal. Then you add up together and you put on the wheel. So you found that this one, yeah, for the outer wheel. How do you know it is outer wheel? Remember, as you the vehicle, this one turn here. This one is right. So all this part becoming inner. This one becoming outer. This one is inner. This one is outer wheel. So this one is outer wheel. So you have here, here, here. Every force here pointing upward, right? But you find this one pointing upward, this one is pointing downwards. So to ensure that the vehicle, the wheel will be remain stationary. Sorry, it's not stationary now. To ensure the wheel will remain on the ground or on the surface and will not leave the surface. So you can define this one, what you call stability. This one must be equal to that one, or static must be equal by dynamics. Then you will have V here. So I put it there. In such manner. This one here, I will have as such for the output, out wheel, for the inner wheel. This one you cannot do anything about it. This one, yes. for stability. You use the equation, this one, then you equate, you found the velocity. The velocity is about 133.24 kilometer per hour, or perhaps equivalent to 37.01 meter per square. So this one be the limiting speed. In such manner, if, for example, yeah, you exceed the limit, what happened? So the wheel will tendency to leave the ground. How are you going to prove that one? So that is another what you call CTPS equation. Check which wheel has or have tendency to leave the ground, the surface. Okay, if the question keep asking you this one, what happened to the structure, for example, yeah, or perhaps what happened to the body now? Okay, another one, what happened to the body? Effect on body, effect on body. So how is it? It is not very difficult for effect on body. You have two equations. Your equation here, this one, yeah, this equation and that equation. You look at PO, find PO. Find PO, don't put the V is equal to 37 just now. So exit the V now. Let's put it to V now is equal to 50, for example. Now let V is equal to 50 meter per second. Because you want to check. Let is exceed then whatever you be calculated earlier for the limitation speed. So you put V now, here, put V this one, and put V50. I do calculate this one, yeah, I already calculate just now. I do find that will bring you to the equation of PO is given by 11 here. You can calculate on your own class. 085.5 Newton, and it is pointing upward. The other one, your PI now, is equal to 3,237.5 Newton, and it is pointing downward. But remember, yeah, this forces 11,000 and also 3,000 here is to the on the wheel, isn't it? So you have to check whether it's leave the ground or not. You have to what? You to inverse the direction to look at the or to find out the what do you call it? The effect. So now inverse it. Inverse it. This one is on wheel. This one is on body. So now you go back to here. Go back to the so you have the PO with pointing downward, the PI with pointing upward. So PO, where is the here? So I'm going to clean up this one. So after you do calculation, putting you found that so this one be pointing upward. PO, yeah, pointing upward. So it's pointing upward just now. It's pointing downward. Sorry, pointing downward. So now I'm cleaning up this one. Is pointing downward. So pointing downward. Pointing downward. PO. This one is pointing upward. So what does this mean now? What does this mean? So it simply means that while turn to left, sorry, turn to right, the inner wheel have tendency to lift the ground. Or perhaps we can show this one as I put it here. So the inner wheel here, this one is the outer wheel. Look at this one is the outer wheel, stick to the ground. This one the inner wheel, leave the ground. This one is PI. This one is P. This one is one. You understand or not, class? Thank you. Thank you, Yako. So this is if the question keep asking you about what happened to the body. Yeah. Otherwise, you just leave it like that. Yeah? So typically they were asking you two parts. Yeah. One will be what will be the maximum speed, for example, as what we did earlier. The other part is to check and balance where will be the possibility of wheel leave the ground while turn to left or turn to right. The other possibility on this particular topic will be when you hit a pothole. Again, yeah, when you hit a pothole, if I can share you a bit, we have. I need to.
Doctor, can I ask you a question just to confirm?
Yes.
So for the
Can you please
vehicle,
speak up, please?
basically we will have three effect on the tire, right? One from the vehicle weight, then the gyroscopic, and then the centrifugal, right?
Correct.
Uh,
Absolutely.
okay. Thank you, doctor.
Okay. Basically, in the actual one, you have four, yeah, as I mentioned earlier, the drag friction, but you don't learn the drag friction here. So let's ignore the drag friction, but you have to put in your mind that basically you also have another one due to the drag friction. But now we are going to not neglect the drag friction because it's not part of our topics. Okay. So if you totally calculating what happened to the wheel, you need to insert or you need to include the drag friction. But basically, we are going to ignore the drag friction. We are assuming that the design of the vehicle will not basically put so much force on the structure. Okay, that is our assumption. Okay, if there's no any other equation, yeah, you can read back this one. You go back here and you can do on your own. This is the alternative solution, as I mentioned earlier. What you did in dynamics, remember? What you did in dynamics basically the same, but finally you do not know. You end up with you don't know which will have to maintain the ground because what you learn in dynamics basically to look at what will be the force. Number 7, you can do on your own. Look at here, force on each wheel when the car travels 20 meters per second. Then you have to look what happened to the force on each wheel. So on and so forth. I think you have 2 or 3 work example typically related with the vehicles. Yeah, try on your own class. Okay, so I'm going to help you, or perhaps to extend a bit here, just to share with you how to solve this couple of problem in your assignment. And I also gave you the deadline of submission date on the just copy effects assignment. Yeah, excuse me. This one is not very much difficult. I'm going to pick up a very rare equation where you found that uh, it's not difficult but very tricky. For example, yeah, example number 10. Oh, sorry, problem number 10 on page 189. So this one. Here, this one, number 10. I try to solve this one. Okay. What you have is show a rigid body carries motor supported by a spring with a stiffness of 120 kilometer, a pin at A and B. So you have a pin at A and B here, A and B, correct? And what else? They also provide the motor drive a propeller rotating with 2000 RPM, counterclockwise viewed from the direction shown. So if you're standing in front of the propeller running with the speed of 2000 RPM, it is rotating counterclockwise here. So counterclockwise, this one is counterclockwise, so it will be pointing that way. This one is clockwise, be pointing inward of the motor. So this one will be your spin, for example. Yeah. And on the uh, same time, yeah, the mass of the domination given, the propeller also given. If the rigid frame rotating at the vertical axis with a speed of 50 rpm clockwise bandwidth from top, calculate the changes length in spring. So what will be the changes length? You learn in dynamic, it's not the changes length. You learn dynamic is extension. The changes length is basically the actual length, oh yeah, minus by the the new line is one for example. So you have the extension. If you have begin that negative, it means that it is compressed. You have a positive, it means that will be in tension. So that's what you learn this one in dynamics. Okay, so we are going to look for this one. How much the tension on the spring now? We do not know yet at the moment. What we do know that if you look at this one from top, we have omega. From top here, you have this one is rotating. What does it mention here? Rotating clockwise. So clockwise, you are sitting at top. clockwise will be pointing downward, correct? Clockwise, yeah. So this one will be the precession. So if I can construct again these the the thing that you have there, you can open up your books. You don't have to copy this one, the whole structure. So what you do have here is the structure. This one, oh, very quick one. Yeah, we don't have much time here. The structure. This one is the motor. This is a spring. Then we have a motor here. Then you have pivoted here. Then you have a propeller here. This one is a motor. It's a propeller. You are viewed from one end, and the propeller is rotating with a speed of 2,000 RPM counterclockwise from this position. So at the same time, you have this one is of course supported by bearing and another bearing. This is the base. And if you look at or you view from top here, this one is top view, you find that it is rotating with a speed of 50 RPM just now, clockwise, yeah. So if clockwise mean then, so from top clockwise. So let's now, and this one is point A, this one is point. Let's say this one is slender rod, for example, yeah. Okay, or pin, for example, slender rod with pin. This one pin, this one another pin, because I draw quite long here. It's supposed to be very close, yeah. So anyway, our concern is first to define M as usual is I omega cross precession. The I now, you look at the I, they provide you I as what you have for I just now is the propeller rotating part is 2 kilogram per meter, so you don't have to do anything about it. We have to put it at 2 kilogram meter square. This spin velocity is 2 pi by 2,000 divided by 60. You will have this one in radian per second. Okay, and you have the precession now also defining by 2 pi by n is 50 radian RPM, so divided by 60, you have another 1 radian per second. So you can calculate this one easily. Then finally, you'll be getting as such I is equal to something Newton meter. It's not I. Astaghfirullah, it's not I, yeah? It's M. M is something in Newton meter. Could anyone tell me what you have here for a moment, for couple here? I don't have calculator with me now at the moment. So could anyone tell me what you have M here? Anyone? Who's good in calculating or in punching in value, the value in calculator? Could you please give me the numbers? What do you have here, class?
2194.
2194 Newton meter, correct?
0.93.
Thank you very much. Yeah, 2194 Newton meter. Okay, now, so that's about it. Yeah, so
93.
2194.3, correct?
93. 93. Yeah. All right.
2193, correct? 94.
Yeah.
Point.
9.9.
0.9. 3.
3. Yeah.
Put it there. It's 0.9. Just put it at 195. Okay, so 195. So that is the M, yeah. And you know that this M is equal to F multiplied by, that is A and B, correct? Because the pin is on A and B. If you go back to the equation, figure, the one is A and B with a distance of 0.5, isn't it? So yeah, from this one to that one. Okay, that one. So this distance, so that will affect on the deflection. So you will have here, the F now is equal to 2195 divided by 0.5. So that will give you twice, about 5,000. Correct? You will have 4,380. Correct? Newton. Am I correct? Yes or no?
Yes.
Okay, this is F. So you know what F now. So now, so we are focusing on now gyroscopic vector diagram. Okay, so what you have here, if you look at one point rotating clockwise, sorry, rotating counterclockwise, okay, this is rotating clockwise, guys, pointing that way. Rotating counterclockwise will be pointing to you, sorry, pointing the other way. So you have this one is zap, astaghfirullahaladzim, sorry, yeah. You will have the omega or the spin velocity will be pointing that way, am I correct? And when you are looking from top here, a rotating clockwise and rotating counterclockwise. So for clockwise, it will be pointing downward for the direction of rotation. Oh, sorry, direction of vector. So you have this one, the precession. Are you agree with me, class? So put it in spin, the precession. The next one is your couple, and couple be pointing inward on your screen. So you have couple here, couple. This is couple, active. This is the active. Okay, so the reactive, because we want to look for what happened to the structure, because the question tells us to do so, isn't it? So you have this one, the M reactive. So we are focusing on M reactive, the M reactive here, M reactive. And the M reactive, we have the M reactive, you have M active is equal to M reactive, basically, isn't it? We already understand this one by applying the principle of action equal to reaction. And of course, you do found that the F now is exactly the same, 4380 here. Doesn't matter whether active and reactive now. So as the reactive now, because you're concerned about a vector, so it is pointing to you now. As it is pointing to you or pointing to me, be rotating the other way. This one, it'll be pointing this one. So from your point of view, be rotating counterclockwise. This one is counterclockwise. Yeah, this one, take this one and put it in this structure. So now be rotating or pointing that way. M reactive. And you already know that the force value is 4380. So where will be the force acting now? The force will be acting this one, am I correct now? To comply this M, this is the force. This one will be another F. And the value will be 4380 Newton. This one is 43 Newton. Am I correct or not? Yes or no? Yes or no? Okay, now, so what happened to the extension now? Remember, F spring is equal to delta, or perhaps you are not using delta, right, in your dynamic. Put it just kx, but basically it's k delta, where your delta is equal to extension, or your x also equal to extension. Okay, so your x now is equal to, or your delta now is equal to the F that you calculated earlier as 4380 divided by the K. They provide you the Ks. What is the K? 120 kilonewton times 10 to the power 3. You'll be getting as such. So what you have here? Anyone? Anyone? Could anyone tell me what would be the numbers here? What would be the value here?
0.003.
Meter, correct?
0.037.
37. It's
Yeah.
meter, right? Or
Meter, yeah.
equivalent to 37 millimeter.
Oh yeah, Doctor, by the way, the 4380 is
Sorry?
4390.
390. No, it doesn't matter. You can calculate it on your own as long as you know that how to get it in, isn't it? So put this number is correct, assuming the number is correct. Okay. So now you know that that is the extension. What you do? There is a number here. You do not know whether it's extension or not. Sometimes the extension can, the extension, don't get me wrong, yeah. This extension
The
value
4380 to 4390.
43 4380. Why? Where do I go get wrong? Okay, doesn't matter. So delta is equal to x is the extension. Remember the extension, it can be tension, it can also be compression. We do not know. The tension will give you the positive value, the compression will give you negativity, which we do not know. But we do know that this one is 37 millimeter, and we do not know which to which. Okay, then you go back to this one and you look at to the structure. So as you push this one downward, so this one it will be prolonged a bit, isn't it? This one become prolonged a bit. Correct or not? It become extension in terms of tension. Become longer. Then you put it, it is a extension for tension, isn't it? For tension. It's not for due to the compression. Okay. Any question?
Doctor.
Okay. Yes.
For the car, the M active will be the action on the wheel and the engine, and the M reactive will be the action on the vehicle body. So, for this question, since it don't have the wheel and the wheel, so the reaction will be the body. The reaction will directly be the act on the body of the engine that you draw just now, right? The motor.
Correct. Okay. For the vehicles, yeah, remember this. For the vehicle, you basically concerned about what? Wheels, right? Because the wheel make the system or the car move, correct? So whatever you have is basically the active on the wheel. You get what I mean? You
Yes,
get what I
Doctor.
mean? So on the wheel. Okay, so everything you calculated is on the wheel. But if, for example, the question asks you what happened to the vehicle, so you need to know what you need to know on the body is the reactive now. It is very difficult different from what we have earlier or in here. This year, these topics, we basically focus on the reactive because we know that whatever you get is the active, and we are okay. Okay, now tell me, where is the active now? This one, the M active. This M active belong to where? You tell me. Remember, this is due to propeller. Am I correct or not? Propeller. Am I correct or not?
Yes, okay.
Yes or no? This is due to propeller, isn't it? Correct? So it is. We are not talking about propeller. No, we're talking about what? We are talking about things that support the propeller. Am I correct? Yes or no?
Yes, doctor.
Isn't it? But in the vehicle, you're talking about wheel. Whatever you calculated is basically on wheel. Okay, whatever you calculate is basically on wheel. For example, this is a car, yeah? You calculated this on mg. I agree to you, this one is mg. Mg always pointing upward. So this is one. This is wheel to, this one is, sorry, this is body to, this one, body to surface, isn't it? Body to surface. What happened to wheel? So but there must be another force acting on this one. We do not know what force this one. What we do know this one is basically the same one but acting different direction. So you have this one mg, because we have 4 wheel divided by 4, this one divided by 4. You get me or not? So this one on wheel, force now on wheel. This one is force on what? Tell me. This one force on what?
Wait.
On
Okay.
on this is, you calculate this
On
one mg on
surface. On the
surface.
surface.
On surface. Okay, this
Oh,
one on wheel. Correct. This one is on wheel because you are concerned about wheel. Okay, you get what I mean. Then after calculating everything, yeah, then you have the force. Then that is the force on wheel, and you want to know what will be the force on the body. So everyone will be now opposite. So on wheel, on body, you are talking about this one now. Agree or not? The actual thing.
yes.
Okay, so it's very different from what we have earlier. So you have to understand this one. Remember this one. Whatever you calculate, whatever you calculate, the M now is basically a thing that make the system move or rotate from one station to another station. For example, a propeller of the one of the aeroplane. We are calculating that one. Where is the effect? The effect will be on bearing. Why? Because the bearing hold the propeller. And what the effect? The effect is on body. Correct. Same thing like the boat, for example, but not on the vehicles. The whole vehicle, that everything you calculated is basically the force on the structure, sorry, on the surface. But you know, you want to know on the wind. So there must be another force acting on the wind, which coming from the surface. Why? Because it's solid ground. The aeroplane and also the vehicle, sorry, the aeroplane and also the ship do not have a solid ground. That you punching, punching on water, you don't feel anything. You punch a propeller just now. Or for example, for the vehicle, which force make the system move? It's a wind, right? So the moment active is on wind. If you're talking about propeller, you're talking about turbine, so the moment is due to the turbine. Then you want to look for what? Bearing. So you have to look for the reaction on bearing. So the M that you calculated, this M here, you calculated from the principle here, and also you applying this one from the gyroscopic vector diagram is all the thing that make the system move or rotate or fly or steer on water, for example, or a vehicle on road. Okay, the other thing you want to look for is basically the reactive. Then you found that the magnitude will be going to be the same, but not the directions. Sorry, I'll hold you 4 minutes. Yeah, sorry for that. I really hope you understand. If you want to more, if you want to have more information, you read the book. Inshallah, you'll be getting enough information just to solve the problems. Yeah. So if there is no question, I'm sorry, I have to close the session. Hope to see you again on Wednesdays. We jump to another topic on the balancing. So I really hope that you understand these topics. And this is not a very difficult topic, but interesting and so a bit tricky compared to the others. So with that, I end my session. And thank you, class. Hope you enjoyed the class. See you again, inshallah, on the next topic. So I would like to end my session with Assalamualaikum warahmatullahi wabarakatuh. You stay safe, stay healthy, also stay study. Thank you, class.